everyone, we're going to finish section 7.3 today. So you can see on our screen here all the things from 7.3. We already did gradients. We already did finding the gradient at a particular value of x. We already did the equation of the tangent line. So today we're going to focus on the equation of the line perpendicular to the tangent line, and that line is called the normal line. So we're going to learn today how to find the normal line to a curve at a given point. You will be happy to know this uses the same equation that we did yesterday. So if you understood the material from yesterday about the tangent line, this should not be a big step to get to this one. So remember we said that AB, we usually call that x sub 1, y sub 1. And so our equation here would be y minus y sub 1 equals m, right? Remember the derivative at a specific point is the gradient, x minus x sub 1. And then we can rearrange this into whatever form that we want. So we're just going to use that same equation today, except that instead of finding the tangent line, we're going to be finding the normal line. Okay, so write this part down. A normal line to a curve is a line which is perpendicular to the tangent line at the point of contact. So if you need to pause the video just for a second so you can write that statement down, that is an important statement. All right, here is a picture that will go along with that. So the red is the original curve that we had, whatever it was. The blue line is what we worked at yesterday. That's the tangent line. You can see it touches the graph right there, but doesn't go through it. And then the green one, the normal line, you can see that that one is perpendicular to the tangent. I've got a right angle right there. So to find the gradient of the normal line, you just do the opposite reciprocal of the tangent. So I know that we said to show that two things are perpendicular, you don't talk about opposite reciprocals, you talk about how they multiply together to be -1. But to find it, you want to do the opposite reciprocal. So basically, I'm going to find the equation for the derivative. I'm going to plug in that point. Then I'm going to take the reciprocal of it and change the sign, and that's going to give me the gradient of the normal. Okay, so let's look at that. All right, here's our first one. We want to find the equation of the normal line. All right, so focus on that, the normal line of this particular curve at the point where x equals 0. Well, the normal line is perpendicular to the tangent line. Tangent line always makes me think derivative. So first thing I'm going to do here is take the derivative. The derivative of x squared, bring that 2 down in the front, 2x. Minus, and the derivative of 4x, 1 times 4 is 4, and then remember that becomes x to the 0 power, which is 1, it multiplies away, and then the derivative of 3 is 0. So there's my derivative. I want to find the value when x equals 4, so I'm going to substitute in 4. Putting in 4 for my x, 2 times 4 is 8, 8 minus 4 is 4. Okay, so now let's think about what we have found here. That 4 that we have just found is the gradient of the tangent. And I know that to be true because I took the derivative, and the derivative gives us the gradient of the tangent line. Well, I don't want the tangent line, I want the normal line. So the gradient that I want to use, I'm going to take that 4 and do the reciprocal and then change the sign. The gradient that I want to use is -1/4. Okay, so just like yesterday, I now have the gradient that I need. I also was given the x value that I need up here. There's x sub 1. What I still haven't found is y sub 1. Well, that turns out to be exactly the same thing as what we did yesterday. So I'm going to take that 4 and substitute into the original equation in place of all the x's. All right, and then I'll work this out. 4 squared is 16. 4 times 4 also 16. 16 minus 16 is 0 plus 3, which is 3. So there is the y sub 1 that I needed. Okay, now I'm going to take that and I'm going to substitute into the gradient equation y minus y sub 1, which I just found to be 3, equals m, which I said is going to be -1/4. That's the gradient of the normal, times x minus x sub 1 which is 4. Okay, so this time let's practice putting this one into standard form. We practiced with gradient intercept form yesterday. Let's practice standard form today. So if you remember, standard form ax plus by plus, I think they use a d in the formula book, equals 0. All right, so I'm going to erase us some space up here at the top so we can simplify that, get rid of all of this. Okay, so I am going to distribute that negative 1/4, y minus 3 equals negative 1/4 x, negative 1/4 times negative 4, positive 1. Okay, so I need to move the negative 1/4 x and the positive 1 over onto the other side. So I'm going to add 1/4 x and subtract 1. That gives me 1/4 x plus y. Negative 3 minus 1 is negative 4. All right, and then if you remember the rules for standard form, a, b, and d must all be integers. So in order to make that fraction of 1/4 into an integer, I need to distribute a 4 across that whole thing. 4, let me just put that on there. 4 times 1/4 is 1. 4 times y, 4 times 4, and then 0 times 4, which is still 0. So our final answer, if it had asked for standard form, the equation of the normal line would be this. Okay, let's practice doing that again with our calculators. Those of you guys who have the TI-84s at home, hopefully you wrote down the directions from yesterday. Those of you guys using the calculator on your computer, we're going to use these directions. So if you do not have your calculator already up on your computer, pause the video, go ahead and get that calculator out, and then go ahead and type our function into y1. So pause the video at this point. Okay, once you get your function typed into y1, let's follow the directions from yesterday. It says go to the home screen. So I need to quit off this screen, hit the math key. All right, I'm going to arrow down to number 8, numerical derivative, and hit enter. Okay, now I didn't put the little thing up here. Let's see if we can remember from yesterday. The expression. Well, the expression is this, which we just typed into y1. So you remember you're going to go to vars, yvars, enter, enter. All right, there's my y1. And then you see I have the comma right there. So there's my comma. The variable, that means what variable is inside of my expression. Well, that variable is x, comma again. And then what value am I trying to evaluate the derivative at? And that value up here is going to be 4. So I'll put 4, close parentheses, and hit enter. Okay, and you can see it gave me 4, which if you look back, oh, you can't see it because I erased it. That is the value that we got on the last screen when we did the derivative. Okay, so now what have we found here? That is not the gradient of the normal line. That's the gradient of the tangent line. So just like before, the first thing I'm going to have to do in order to find the gradient that I want is flip that upside down and change the sign. So the gradient will be negative 1/4. And then the rest of the problem is just like what we did before. Okay, one more. Let's find the coordinates of the point where the normal to this particular curve, and I want the normal at this point. I want to know where it meets the curve again. All right, so I see the word normal. Normal is the perpendicular to the tangent line. Tangent line makes me think derivative. So first thing I'm going to do here is take the derivative. All right, the derivative of x squared, that 2 is going to come down in front. 2x, 2 minus 1 is 1, so my new exponent is 1. And the derivative of negative 3 is 0. Derivative of any constant is 0, so there's my derivative. All right, and I need the derivative specifically at this point. Okay, so let's analyze what we have here. That 1 is going to be x sub 1, and it's written as a point with y sub 1. So this time they already gave you y sub 1, but you do still need to find m. All right, so let's substitute in y prime of 1, 2 times 1, which is 2. Okay, so now what is this? All right, well, I substituted that value into the derivative. That always gives me the gradient of the tangent. Well, that's not what I want. I want the gradient of the normal. So the gradient that I want to use, flip that upside down and change the sign. The gradient I want to use is that. So if I substitute into my formula, I've got y minus y sub 1, which this time they gave me, equals m, which I just figured out to be negative 1/2, times x minus x sub 1. Okay, minus a negative right here becomes plus a positive, y plus 2. I'm going to distribute the negative 1/2, negative 1/2 x, negative times negative is a positive 1/2. All right, now I'm looking at the directions here and it says I want to know where this meets the curve again. That tells me I'm going to want to use the intersect feature on my calculator. So because of that, I'm going to work to get y by itself. So I'm going to subtract y from both sides. And 1/2 minus 2, that's 1/2 minus 4/2, which is negative 3/2. Okay, so now let's figure out where this one meets this one. Okay, so I have put something up in Desmos here for us. All right, and you can see there is x squared minus 3. That's the green one. There's the tangent line. You can see it touches the curve in that one point, and the point is 1, negative 2, just like it asked us in the directions. And now that red one that I just put in there, that's the normal line. You can see that the blue one and the red one intersect one another right there. And then the red one intersects again over here. So that's the point that I want for my answer, negative 1.5, negative 0.75. So since you're going to be working from home for a while, if you want to do that with Desmos, that will be fine. I know you guys know how to do that on your regular calculator as well, but if you want to find that point on Desmos, negative 1.5, negative 0.75, and I'll come over here and write that down as the final answer, negative 1.5, negative 0.75. So in using your resources, it's okay to use Desmos at this point since you're going to be home for a while. Okay, that's all there is to finding the equation of the normal, the equation of the tangent, and then you just adjust the gradient. So at this point, you can finish your homework from that particular section. From 7.3, you are ready to finish all the homework. And the little button to turn the thing off went away. You can turn the video off. There it is.